Alright, today our video is part 2 of objective 6.1. We're still graphing exponential functions based on their key features, but you notice now we've got some new changes. We've got a vertical shift. This has gone up 7, and we also have a horizontal shift. This has gone left 2. These are the same rules they've always been for transformations, but it will make this a little more complicated. So we used to start with a and b. This time we're definitely starting with the asymptote. Now the asymptote in the previous video was at y equals 0, and in this video it's going to be at y equals 7. Okay, so the asymptote is always affected by a vertical shift, and it's not affected by anything else. So none of these other things affect the asymptote. So basically whatever the vertical shift is what your asymptote is, and that will be that way every time. So I'm going to go up to 7 and I'm going to put a horizontal dotted line here. Now, again, just a reminder, what that means is that when we graph this on one side or the other, the left or the right, it's going to get closer and closer but not touch that asymptote. And you're going to see some examples too, some that are above and some that are below, but it'll never cross or touch this line. Next thing we're going to do is look at our a. So our initial value here is 3. And then, again, just like last time, I'm going to look at my multiplier, which is 1/3. This is going to be a complicated one just because it's decay. But really the reason we have a new video here is because of our transformations. So we have left 2, and we've also gone up 7. Now, there are different ways to describe this, but here's how I'm going to do this. The up 7 we've already dealt with the asymptote. The left 2 is going to apply to our initial value. So listen carefully here. Our initial value is 3. Now that wasn't necessarily the number 3. What this actually represents is 3 above the asymptote. So since the asymptote was at 7, that's actually at 10. But that's the last time you're going to hear me talk about the actual numbers of the graph. This was 3 above the asymptote, but I'm moving it left 2. So this point here is going to be left 2 from that. Okay? So this is really, really important. Our initial function, or our initial point, is 3 above the asymptote, because it's positive. And then it's been moved left 2. After that, everything else is going to be the exact same using our multiplier. So since b equals 1/3, as you go forward, you multiply by 1/3. And just as a reminder, that is the same thing as dividing by 3. So here, 3 above the asymptote, if you divide by 3, you get 1 for the next dot. 1 divided by 3 is 1/3, and then it's obviously just really close to the asymptote. Going backwards, going to the left, you divide by 1/3, and that is the same as multiplying by 3. That's usually the way I like to do it because that's easier. So 3 times 3, the next one backwards would be 9. So the next one is 9 up from the asymptote. 1, 2, 3, 4, 5, 6, 7, 8, 9. You notice I'm not actually talking about whatever the actual y value is. Everything is relative to the asymptote. Now, this looks exponential. It's exponential decay because it's decreasing because b was less than 1. And then you can draw it. You've got an arrow on the left. And then remember, it doesn't stop there. You get Sorry about that. It goes mostly flat and then flattens out. Again, just like the last video, I can't make this very straight based on my technology, so you just need to know. It gets closer to the asymptote but never touches it. So that wraps it up for 6.1. We have graphed exponential functions based on their key features, which are the asymptote, the initial value or the y-intercept, and the multiplier with transformations.